Just hours ago, on March 16th, a profound contradiction in the laws of celestial mechanics unfolded in the deep space surrounding the largest planet in our solar system. The incoming telemetry has begun to fracture our understanding of planetary gravity and interstellar visitors. An object from beyond our Sun, designated as Comet 3 I Atlas, brushed past Jupiter at a distance of 53 million kilometers, racing through the dark void at an astonishing speed of 61 kilometers per second. At that velocity, and at such a relatively close proximity to a gas giant with 318 times the mass of Earth, the fundamental principles of orbital mechanics tell us something very clear. The object should have experienced a measurable gravitational deflection. Jupiter's immense gravitational well, stretching across millions of kilometers, routinely captures, tears apart, or violently redirects comets and asteroids that wander too close. And yet, when the data streams from the Jupiter Icy Moons Explorer spacecraft were processed just hours ago, the trajectory of this interstellar wanderer revealed something that borders on the impossible. The gravitational influence of Jupiter on Comet 3 I Atlas appeared to be effectively zero. The comet moved through the Jovian system without its flight path shifting by even a fraction of a degree. No visible bending. No detectable perturbation. Nothing. That alone would be extraordinary. But what truly transforms this event into a mystery is what the spacecraft captured visually. The cameras revealed an intensely bright coma and a trailing tail, while the solid core of the comet remained completely hidden behind a dense, opaque cloud of gas, shaped with uncanny precision, like an egg. How can a celestial body moving at 61 kilometers per second, wrapped in a gas envelope so dense that its nucleus is completely hidden from optical sensors, pass straight through the most powerful gravitational anchor in our planetary neighborhood without being pulled even slightly off course? This kind of gravitational ghosting presents a deeply unsettling puzzle about the true physical nature of this object. What we are seeing is a contradiction. The visual size and the intense chemical output of the comet suggest something massive, something heavy, and yet, its interaction with gravity suggests almost no mass at all. These two realities should not coexist. And resolving that contradiction requires us to dismantle everything we think we know about this object, piece by piece. By the end of this investigation, we will understand exactly how this object appeared to defy the gravity of Jupiter, and what that hidden, egg-shaped core is truly made of. But to understand the physics of what just happened, we have to step back a few days and examine the chemical fingerprints this object left behind, because its chemistry is already telling us something unmistakable. This object does not belong here. On March 12th, astronomical observatories, isolating the spectroscopic signature of the comet, detected an overwhelming excess of methanol streaming out of the coma. Methanol is an organic molecule, a simple alcohol composed of one carbon atom, 4 hydrogen atoms, and 1 oxygen atom. In comets formed within our own solar system, especially those originating from the distant Oort cloud, methanol does exist, but only in trace amounts. It is usually a minor component in a mixture dominated by water ice, carbon monoxide, and carbon dioxide. But the spectral absorption lines captured from 3I Atlas told a very different story. The concentration of methanol was not just elevated, it was many times higher than anything we typically observe in local comets. When spectroscopists analyze light from a comet, they search for very specific wavelengths where photons have been absorbed by molecules within the gas envelope. Each molecule vibrates and rotates at precise frequencies, defined by the laws of quantum mechanics, leaving behind distinct dark lines in the infrared spectrum. These lines form what scientists call a chemical barcode, and the barcode for 3I Atlas is unmistakable. It is intense, dominant, and impossible to ignore. revealing an object saturated with this organic alcohol. This is not a minor chemical curiosity. Methanol is a critical precursor to life. It is one of the fundamental building blocks in prebiotic chemistry, meaning that under the right conditions, such as exposure to ultraviolet radiation from a young star or constant bombardment by cosmic rays in deep space, methanol molecules can break apart and recombine into far more complex structures. Sugars, amino acids, the basic organic frameworks required for life as we know it. The fact that this wandering mountain of ice is saturated with prebiotic chemistry transforms it into something far more significant. It becomes a fingerprint of another star system, a preserved fragment of a distant and ancient stellar nursery, formed inside a cold, dark molecular cloud drifting through the galactic disk, where temperatures hover just above absolute zero. In those frozen regions, carbon monoxide molecules slowly settled onto the surfaces of microscopic silicate dust grains. Over millions of years, they underwent a gradual process of hydrogenation, reacting with free-floating hydrogen atoms and building layer upon layer of solid methanol ice. The unusually high concentration of this organic material points to a formation environment completely different from the one that gave rise to our own planets. And as we consider the immense reservoir of life building chemistry locked inside this single interstellar object, another question begins to emerge. What happens when these molecules, formed in deep interstellar cold, are suddenly exposed to the warmth of our sun? Because while the methanol anomaly tells us where this object came from, it does not explain how it behaves now. And that behavior reveals something even more unusual. Something that seems completely disconnected from the influence of solar heating. To understand that, we need to look at what happened in the weeks leading up to the methanol detection. Throughout February and March, the comet displayed a pattern of activity that was both unstable and unexpected. Normally, comet behavior follows a simple and predictable pattern. As a comet approaches a star, solar radiation heats its frozen surface, causing volatile ices to sublimate, transitioning directly from solid to gas in the vacuum of space without passing through a liquid phase. This outgassing releases dust and gas, forming the glowing coma and the long trailing tails that are pushed away from the sun by the pressure of the solar wind. As a result, when a comet moves away from a star, the available thermal energy decreases. Sublimation slows, and the comet gradually fades and becomes quiet. That is the expected behavior. But 3I Atlas did the exact opposite. During February and March, the comet was already on its outbound trajectory, moving steadily away from the sun and descending back into the freezing darkness of the outer solar system. The amount of solar radiation reaching its surface was decreasing with every passing hour. And yet, observatories recorded something completely unexpected. The comet began to flare, violently. Repeatedly, its brightness surged. Fresh waves of gas and dust were ejected into space. Activity increased at the exact moment it should have been declining. This behavior directly contradicts the basic thermodynamic expectations for a receding object. So the question becomes unavoidable. How does something frozen in the vacuum of space generate powerful thermal outbursts when its only external heat source is fading away behind it? The answer is not on the surface. It is hidden deep inside the comet itself, pointing to an energetic process unfolding at the molecular level. When ice forms in the extreme cold and near-perfect vacuum of interstellar space, water molecules do not have enough energy to organize themselves into the familiar hexagonal crystalline structure we see in ice on Earth. Instead, they freeze instantly upon contact, locking into a chaotic, disordered arrangement known as amorphous solid water. This form of ice behaves more like glass than crystal, and it is inherently unstable. As the comet approached the sun earlier in its journey, Heat slowly penetrated through the dusty outer layers and began warming the interior regions of this amorphous ice. Even after the comet started moving away and the surface began to cool, that wave of heat continued traveling inward, deeper into the structure. When amorphous ice reaches a critical temperature, it undergoes a sudden phase transition. Its molecular structure reorganizes into a stable crystalline form, and this transformation releases energy, a lot of energy. This process is highly exothermic, meaning it releases heat from within the material itself. That sudden burst of internal energy rapidly sublimates trapped pockets of volatile compounds such as carbon monoxide and carbon dioxide, which have been locked inside the ice for millions of years. Pressure builds instantly beneath the surface, and then the surface breaks. The result is an explosive release of gas and dust into space. Shock waves ripple through the interior. The comet flares. These internal eruptions explain the sudden outbursts we observed, but they also reveal something far more unsettling about the comet's structure. For gas to escape this quickly, the interior cannot be dense or solid. It must be highly porous, highly fractured, almost sponge-like, which leads to the next question. Just how porous is this object? Really, to answer that, we have to go back further, to a rare and precise alignment that occurred on January 22nd, an event that turned the comet into a perfect natural laboratory for studying the physical structure of its dust. On that day, Earth moved into a position directly between the Sun and the receding comet. In astronomical terms, the phase angle between the Sun, the observer on Earth, and the comet dropped to 0 degrees. And when that happens, something remarkable occurs. An optical effect known as the opposition surge. To understand it, imagine shining a flashlight straight into a dark forest filled with rough, uneven surfaces. Under normal conditions, sunlight hits the peaks and ridges of dust grains. But those same structures cast tiny shadows behind them. What we see is a mix of light and shadow, which reduces the overall brightness. Your telescope sees a mixture of illuminated surfaces and microscopic shadows, and that combination averages out to a relatively dim overall brightness. The fraction of light reflected back into space is known as the albedo. But when Earth moved into perfect alignment with the Sun and the comet on January 22nd, those tiny shadows were no longer visible. From our point of view, they were hidden directly behind the illuminated dust grains. This effect, known as shadow hiding, caused the comet's apparent brightness to surge dramatically. At the same time, something even more powerful was happening. Sunlight was traveling straight into the dust cloud and reflecting back along the exact same path toward our telescopes. The returning light waves interacted with each other constructively, amplifying the signal through a process called coherent backscatter. Together, these effects produced a sudden and intense increase in brightness, an event known as the opposition surge. And this surge gave astronomers a rare opportunity. Because of this precise geometric alignment, scientists were able to measure the comet's albedo with exceptional accuracy and analyze the physical properties of the dust it was releasing. Alignments like this occur only once every few decades for objects on this kind of trajectory, making 3I Atlas a once-in-a-lifetime target for studying raw interstellar material. What the data revealed was extraordinary. The backscatter signature showed that the dust grains surrounding the comet are not solid, compact particles. Instead, they are extremely dark and highly porous, resembling microscopic fractal sponges, or delicate clusters of cosmic cotton. These grains are composed mostly of empty space, held together by weak electrostatic forces and thin bridges of organic material. They are fragile, almost weightless in structure, and when you combine that with the unusually high concentration of prebiotic molecules, It raises a profound question. Are these wandering, hyper-porous interstellar ice bodies acting as carriers of life's building blocks? Transporting organic material from one star system to another, are they cosmic sponges? Seeding the galaxy with the ingredients for biology? Or is this comet simply an outlier? A rare chemical coincidence formed in an unusual region of the Milky Way? Whatever the answer, the chemistry and structure we are observing challenge the idea that our own biological origins are unique. But this fragile, sponge-like structure forces us to confront another question. One that takes us further back in the comet's journey. If this object is made mostly of empty space and delicate ice, how did it survive its passage through the most hostile region of our solar system? On October 30th, 2025, Comet 3I Atlas reached Perihelion, its closest approach to the Sun along its hyperbolic path. At that distance, it was exposed to intense solar radiation and a relentless bombardment from the solar wind. A continuous stream of high-energy protons, electrons, and charged plasma flowing outward from the solar corona. As the comet plunged into this plasma storm at speeds reaching hundreds of thousands of kilometers per hour, it entered a state of extreme activity. The intense heating caused surface ices to rapidly sublimate, violently releasing gas and dust into space with extraordinary force. The outflowing material expanded outward, colliding with the incoming solar wind and forming a massive bow shock, similar to the wave that builds at the front of a ship moving through water. Observatories tracking the comet during this perihelion phase measured ejection speeds of gas and dust exceeding 240,000 kilometers per hour near the Sun. The sheer violence of this outgassing should have torn a fragile, hyper-porous body apart. And yet, the comet held together. It survived the encounter, accelerated out of the inner solar system, and continued on toward its closest approach to Earth. On December 19th, 2025, the comet passed our planet at a distance of 270 million kilometers. A safe distance, but close enough to be clearly observed. And during that winter approach, something remarkable happened. Far from the glow of city lights, observers looked up and saw it with the naked eye. An interstellar visitor, visible without a telescope. A rare and fleeting event. But 3I Atlas did more than simply appear. It transformed the night sky. A luminous green coma surrounded its hidden core, with a long, sweeping tail stretching across the darkness. And that green glow was not just a visual spectacle. It was a precise chemical signal. The color comes from diatomic carbon, a molecule made of two carbon atoms bonded together. When these molecules are released from the comet's nucleus and exposed to intense ultraviolet radiation from the Sun, their electrons absorb energy and jump into an excited state. Almost instantly, they fall back to their ground state, releasing that energy as photons in the green region of the visible spectrum. This process, known as fluorescence, creates the eerie green halo around the comet. But the glow remains confined to the coma. It never extends into the tail. Because diatomic carbon is fragile, under continuous exposure to solar ultraviolet radiation, the molecule eventually absorbs enough energy to break apart completely. A process known as photodissociation. The bond is destroyed, leaving behind individual carbon atoms that no longer emit visible light. The molecule is erased before it can be carried into the tail. The fact that this comet produced enough diatomic carbon to be seen with the naked eye from 270 million kilometers away tells us something profound. It contains an enormous reservoir of complex organic carbon compounds embedded within its ice. And when we connect all the observations, the intense carbon output in December, the opposition surge in January, the violent internal flaring in February, and the methanol detection in March, a consistent picture begins to emerge. This is not a typical comet. This is an object that is fundamentally alien to our solar system. And that strangeness was evident from the very beginning. On July 1st, 2025, when astronomers first detected a faint point of light moving against the background stars, they began tracking its motion immediately, night after night. They mapped its position, calculating its orbit. From that data, they determined its orbital eccentricity. In astrophysics, eccentricity measures how much an orbit deviates from a perfect circle. An eccentricity of 0 corresponds to a circle. The planets in our solar system have values slightly above 0, forming gentle ellipses. Comets from the distant Oort cloud typically have eccentricities close to 1, following long, stretched paths that eventually return them to the Sun. But 3I Atlas was different. Its eccentricity was greater than 1, and that changes everything. An eccentricity above 1 means the object is not bound to the Sun at all. It is on a hyperbolic trajectory, carrying too much kinetic energy to ever be captured. It is not orbiting, it is passing through. After this brief encounter, it will continue outward, crossing the boundary regions of the solar system and returning to interstellar space, disappearing into the vast darkness between the stars. Its origin beyond our system was confirmed almost immediately. But the deeper the chemical analysis went, the more the mystery grew, because when scientists examined its elemental composition in detail, they found something unexpected. A complete absence of the typical metals and silicate structures that are commonly found in objects formed within our own solar system. Instead, what scientists found was a heavy concentration of rare isotopes. Isotopes are variations of the same chemical element, with the same number of protons in their atomic nucleus, but a different number of neutrons, giving them slightly different atomic masses. By measuring the ratios between specific isotopes, such as carbon-12 to carbon-13, or nitrogen-14 to nitrogen-15, astrophysicists can reconstruct the exact environment in which that material formed. And the isotopic signature of 3I Atlas does not match anything in our solar system. Not the Sun, not any planet, not any moon, not any known comet. Its chemical fingerprint is unmistakable. This object formed in a completely different stellar system, inside a primordial disk of gas and dust surrounding another star, billions of years ago in the cold, dark regions of the galaxy, Perihelions. It drifted silently through interstellar space, preserving the chemical memory of its origin, until it was suddenly awakened by the intense radiation of our Sun. And that brings us back to the contradiction that started all of this. Just 24 hours ago, on March 16th, we saw something that should not have been possible. We have examined the alien chemistry, the internal energy bursts, the hyper-porous dust, and the hyperbolic trajectory. We know this object is ancient, organic-rich, and fundamentally different. But none of that explains why an object moving at 61 kilometers per second, passing Jupiter at a distance of 53 million kilometers, experienced absolutely no measurable gravitational deflection. The spacecraft observed something else. A massive, dense, egg-shaped cloud of gas completely hiding the nucleus. In normal comets, the coma is roughly spherical, because gas escapes more or less evenly from the side facing the Sun. But here, the elongated egg shape suggests that gas is flowing in a very different, highly directional way from the hidden core. That dense cloud creates an illusion. It makes the object appear large, and by extension, massive. But gravity does not respond to appearance. It responds to mass. Our models assume that a large object has a certain density, a certain mass relative to its volume, and the gravitational force between two objects depends directly on those masses. If this comet were a solid body of ice and rock matching its apparent size, Jupiter's gravity would have pulled on it. Its path would have bent, but it did not. And the answer to that mystery has been in the data all along. Think back to January. The coherent backscatter revealed that the dust is not solid, but extremely porous, like cosmic cotton. Think back to February. The violent internal flaring showed that the structure is fragile, fractured, and filled with trapped energy. Now bring those pieces together. The truth is both unsettling and elegant. The nucleus hidden inside that glowing, egg-shaped cloud is not a dense object at all. It is a vast, hyper-porous fractal structure. A fragile web of amorphous ice, methanol-rich organics, and loosely bound dust, containing an enormous amount of empty space within it. It has volume, but almost no weight. That is why it can produce such an enormous coma, releasing vast amounts of gas and dust, while still remaining nearly massless in gravitational terms. Its density is so low that it behaves almost like a ghost, a structure made of frozen vapor and dust. And when an object with almost no mass moves at 61 kilometers per second, gravity has very little to act on. Jupiter's gravitational field extended across 53 million kilometers, but there was almost nothing there for it to pull. So the comet passed through, like smoke slipping through a chain-link fence, unaffected, unbent, continuing on its hyperbolic path back into interstellar space. In the end, we did not solve the mystery by changing our understanding of Jupiter. We solved it by changing our understanding of the object itself. Not a solid body, but something far stranger. A structure that looks massive, behaves dynamically, carries complex chemistry, yet is, in physical terms, almost nothing at all.